fuselage, a large main rotor on top, a long tail stretched behind, and a small rotor spinning continuously. But with coaxial twin rotor technology, like the Rotor X uses, everything changes. Two main rotors spin in opposite directions on the same vertical axis, completely eliminating torque. The result? No need for a long tail, greater agility, higher speed, and reduced noise. This is exactly the reason why China is so eager to possess this technology, even if it means copying or espionage. Once we understand why helicopters traditionally require a tail rotor to balance torque, another question arises. Where does the forward thrust of a helicopter come from, since it does not use jet engines like a fighter? How does a helicopter actually surge forward? The answer again lies in the main rotor. When the rotor tilts forward at a certain angle, it not only generates vertical lift, but also horizontal thrust, pushing the helicopter ahead. But here, a natural limit appears. The tilt angle of the rotor is restricted by mechanical design, so the forward thrust can never be too strong. This is why helicopters are always slower than fixed-wing aircraft. Take the UH-60 Black Hawk, an icon of U.S. Army aviation. Even as one of the most advanced military helicopters, its maximum speed is only around 295 kilometers per hour, and that is already the extreme limit for traditional rotorcraft. Faced with the speed limits of conventional helicopters, military designers began searching for breakthroughs. Instead of relying on a small tail rotor to balance torque, they asked, why not place two large rotors on the same axis, spinning in opposite directions? That way, the torque from each rotor would cancel out completely. The result? No need for a tail rotor at all. This bold idea became reality in the Russian Kamov Ka-52. With two counter-rotating rotors on a single shaft, the Ka-52 does not require a long tail or a tail rotor. The design is more compact, more agile, and has the potential for greater speed. But technology is never perfect. The Ka-52's coaxial rotor system uses flexible hinges, meaning the blades are not fully rigid, but allowed slight vertical and horizontal movement during rotation. This gives the Ka-52 good maneuverability, but also creates challenges during complex flight maneuvers. When the helicopter executes sharp turns, sudden directional changes, or rolls, the uncontrolled motion of the flexible rotors can affect stability and safety. Here lies the difference in approach. Russia, the United States, and even China each have their own solutions to the problems of speed, agility, and torque. But one thing is certain, the coaxial twin rotor design is becoming the global trend. And that is why America's Rotor X has become the model China is desperately trying to copy. Even though it is praised as one of the most advanced attack helicopters of Russia, the Ka-52 still carries within it a deadly weakness: rotor blade collision. The very structure that defines it, two counter-rotating rotors on the same axis, was thought to be an ultimate advantage, but in reality, it hides a lethal risk. Looking back at June 17, 1998, a Ka-50, the predecessor of the Ka-52, was caught in powerful, turbulent airflow. The two rotors struck each other mid-air. The helicopter immediately lost control, plunged, and was completely destroyed. This was not an isolated accident. During the war in Ukraine, many Ka-52s have continued to suffer the same fate, especially when flying low, executing combat maneuvers in chaotic air conditions. For Kamov Design Bureau, the developer of the Ka-52, the problem of rotor collision remains a challenge without a perfect solution. To reduce the risk, engineers had to extend the distance between the two rotor levels, but this increased the total height of the helicopter to over 5.2 meters. The result: although the Ka-52 eliminates the need for a tail rotor, it loses the advantage of compactness. The overall size size and space it occupies are no longer reduced as expected. Beyond blade collision, the Ka-52 also faces severe vibration and uneven resonance during heavy loads or aggressive combat maneuvers. This is the direct consequence of using flexible rotor blades, good for absorbing shocks, but unstable during high-speed maneuvers. The Americans, of course, did not stand aside in this race for rotor technology. Their answer was the Raider, and its advanced version, the Raider X, a completely different approach. Instead of using flexible blades like Russia, the US developed a rigid coaxial rotor system, stable, precise, and easier to control during high-speed maneuvers. But torque elimination was not America's only solution. There is another legendary design, the CH-47 Chinook heavy transport helicopter. Rather than coaxial rotors, the Chinook mounts two massive rotors at the front and rear of the fuselage, spinning in opposite directions. These rotors cancel torque, while also providing both lift and forward thrust. The result is extraordinary efficiency. The key lies in precision engineering, the exact calculation of rotor spacing, rotation speed, and shaft length. This level of technical mastery is something China has yet to replicate. Each nation has its own path. Russia prioritizes close-range agility and speed. The US pursues stability, flexibility, and unmatched velocity. And China still struggles between imitation and adaptation. But one truth stands clear. The core technology remains far out of their reach, compared with Russian Ka-52s and Ka-27s, which constantly risk blade collisions. The Raider X, developed by Sikorsky and Boeing, demonstrates a leap far beyond. The key to Raider X's success is the combination of rigid coaxial rotors on top and a pusher propeller at the tail. This propeller is not for balancing torque like a traditional tail rotor. Its sole purpose is to generate forward thrust. Thanks to this design, the main coaxial rotors no longer need to tilt to create forward motion, as in conventional helicopters. The result? A revolutionary improvement in flight performance. In fact, the US had pursued this idea decades earlier. Back in 1967, Lockheed Martin developed the AH-56 Cheyenne, a bold and innovative design. The Cheyenne used a traditional main rotor and a tail rotor for stability, but it also added a second pusher propeller at the rear to provide forward thrust. This meant the Cheyenne's tail carried two separate rotors, one for stability and one for speed. The idea was ahead of its time, but the project was plagued with problems. During test flights, the helicopter suffered from rotor instability at high speeds. Eventually, the AH-56 program was terminated, yet the vision did not die. Its daring concept became the foundation for the